Hello everyone, my name is Zeeshan and I'm joined by my team.
Hello everyone, my name is Zhengtao Zhou. I'm a mechanical engineering student.
Hello, this is Soptorsi Shrestha. I'm doing ENGG in Electrical and Computer Engineering.
Hello, my name is Touqeer Nawaz. I'm doing Masters in Chemical Engineering.
Hi, my name is Johann and I'm doing ENGG in Mechanical and Manufacturing.
And we're Team 27, and in this video we will be diving further into our case study using the morbidity and mortality case presentation structure. So the goal of this presentation is to analyze the cognitive and system issues that played a role in the Texas refinery disaster. We will also discuss what lessons were learned in the aftermath and the actions that were taken to prevent such a disaster from ever happening again. In the end, I will talk about the bottom lines and what we can take away by studying this case. Now, to give you a brief summary of what happened at Texas, during the isomerization unit startup on the afternoon of March 23rd, 2005, there was an overfilling of the raffinate tower that led to a leak of a flammable liquid that was then ignited. This caused an explosion in the refinery and that killed 15 people and injured 180 other people. There were also losses of over $1.5 billion. And this was a huge tragedy that changed the industry forever. To move us further, Johann will continue with some beliefs and biases that were present in this case.
I'm now going to discuss the cognitive beliefs and biases contributed to the BP Texas City refining disaster. First, normalization of deviance. Over time, workers began to accept inadequate safety procedures as normal because they hadn't led to major incidents before. This culture led to people to underestimate risks even as dangerous behaviors became routine. Next, we have overconfidence bias. Engineers and managers overestimated their ability to control processes and handle emergencies. Despite warning signs, they believed a major accident was unlikely, relying too much on their knowledge and past success. We also have anchoring bias. Decision makers focused heavily on early assessments like outdated risk reports and failed to update their views as the condition of the refinery equipment worsened. Another factor is a sunk cost fallacy. With so much money already invested in the refinery, leaders were reluctant to invest further in necessary upgrades or maintenance despite clear signs that the equipment was deteriorating. Lastly, we have the availability of heuristic. Because no major incidents had occurred recently, decision makers underestimated the likelihood of a disaster. The lack of recent failures made the risks feel less urgent. These biases, whether it's normalizing risk, overconfidence, or being anchored to past decisions, played a key role in allowing unsafe conditions to persist, ultimately leading to the tragic explosion. Now, Mohammed will explain the system issues in this case.
Okay, thank you, Johan. According to investigation reports, many system issues were indicated by respective authorities, which were the reasons for this explosion. These system issues are process hazard analysis. PHA conducted for isotope plant found very poor, and there was a risk of fire and explosion. The second one is management of change. All safety changes made at plants were not according to standards, and management did not review the changes to ensure safety at plant. The third reason is audit compliance. All previous audits conducted for safety of ISO plant had deficiencies and suggested corrective actions which were not implemented by management. Next slide. The next reason is failure of company regulations and standards. Major mistakes were found in implementation of company regulations and standards, as vehicle was found in hazardous area, which was the source of ignition. The next reason is poor management system and safety culture. Also, the reason behind this incident because management had cut the budget of safety areas, reduced trainings, and technical staff for increasing profit margins. The human factor involved poor communication system and long working shifts at working place, which contributed in this explosion. Those were the major flaws indicated by different agencies and authorities. Thanks.
I'll be discussing the critical lessons we can learn from the incident. The first lesson learned is the critical importance of prioritizing safety as a non-negotiable aspect of operations. The incident demonstrated that placing financial considerations above safety measures resulted in catastrophic outcomes. Effective safety protocols must always take precedence regardless of cost. Another key lesson is the critical role of leadership oversight. The Texas City refinery incident highlighted significant gaps in supervisory oversight and communication between supervisors and operators. Effective leadership requires active team management, comprehensive training, and an environment where safety is a shared responsibility, empowering all individuals to enhance workplace safety. Proactive risk management is a critical lesson from this incident as well. Engineers must develop systems that are resilient to human error and operational pressures. By adopting a proactive approach, we can significantly enhance safety measures and guard against potential disasters. Moreover, the significance of comprehensive training and heightened awareness cannot be overstated. Downsizing training staff and lacking simulation resources impaired operators' responses, underscoring the need for bias awareness in training to enhance safety preparedness. Moving forward, this explosion underscores the severe consequences of neglecting safety and protocol. By committing to these lessons, we can foster a culture of safety, accountability, and integrity to enhance our operation. Now, Zhengtao will take over.
I will discuss some necessary improvements that can prevent future disasters. First, prioritize safety over cost. Companies must integrate safety into every financial decision, allocating enough resources for system maintenance, safety audits, and necessary infrastructure upgrades. Monitoring systems and automatic shutdown controllers must keep reliable to detect equipment failures in advance and resource possible dangers. In addition, maintaining a sufficient number of technical workers is essential for safety operations. Second, comprehensive training program. From operator to managers, all employees need comprehensive training on high-risk operations like startup, shutdown, and emergency procedures. Mandatory refresher courses should be carried out every 6 months. Workers should also participate in regular drills for worst-case scenarios such as overpressure or leaks to ensure they can respond quickly and skillfully. Third, transparent reporting. There must be a transparent reporting system for every employee to account in any incident or near miss. This includes not only internal investigations, but also external reviews by independent agencies. In addition, accountability provisions should be upgraded to take prompt action for any safety violation. Thank you.
So let's get to the point. On the left-hand side of the slide, we see highlights related to the disaster. The bottom line is that there's a strong need for removing biases, resolving system issues, and to learn from the lessons to initiate actions that prevent such disasters from happening. As a matter of fact, after the disasters, thanks to the high scrutiny towards BP and its affiliates, many actions were taken to improve the standards and regulatory oversight. The main takeaways after analyzing this case thoroughly are briefly shown on the right-hand side of the slide. We have to stress that corporate safety culture is very important, which can only be fostered by corporate leadership. And for that to happen, the leaders must be ethically bound to the responsibility towards whoever might be affected by the operations of the company. This goes hand in hand with process safety, where the design of processes must be targeted to reduce hazards and ensure strict adherence to the system by the employees. Continuous risk management is also needed, which BP failed at, and that can be incentivized by strict regulatory oversight and stringent compliance requirements, which were developed right after this disaster. Lastly, emotions of overconfidence, arrogance should not prevent companies from assuming the worst. This is why the most effective communication channels should be available, especially as part of an effective emergency preparedness system, which was lacking in BP at the time of this disaster. To conclude, we have a huge responsibility as engineers to always uphold the highest ethical standards, not cut corners, and uphold the highest levels of integrity in whatever level of the organization we work in. It was a collective failure that caused this tragedy. An individual effort by all of us can close the gaps of ethical failures. We very well think that BP and the overall industrial sector learned crucial lessons from this disaster. Although, unfortunately, this was at the expense of people being killed and some being harmed permanently. So here are our references, and we thank you so much for listening into our presentation. We will be happy to discuss this case further with the rest of the class in the D12 posts in the future. Thank you so much, and have a great day.